Okay, in this video we're going to talk about one-step equations. Now there's a golden rule you need to remember when you're dealing with equations, whether it's one-step, two-step, or multi-step. And that golden rule is that whatever you do to one side of the equation, you must always do to the other. So let's talk about a few definitions first before we get started. First thing I need to talk about is the solution. The solution in an equation is the value of the variable that makes the equation true, otherwise known as your answer. Inverse operation are operations that undo each other. So if you're adding, the inverse operation will be is how you're going to undo subtraction. Subtraction undoes addition. They're inverses. Multiplication undoes division, and then of course division will undo multiplication. Inverse operations, it's what undoes something else. An equation is a mathematical sentence with an equal sign. Before we've talked about expressions, which is just a mathematical sentence without an equal sign. Now we are dealing with equations. So that's just a few definitions. So another thing you need to remember is when you're solving an equation, the goal is to isolate the variable, and you want your variable to be positive. So if you end up at the end with a negative variable, you need to do something to make it positive. All right, so let's look at our first example. We have x plus 10 equals 15. Remember, we want to use the inverse operation to isolate the variable, or we are getting our variable alone. So x plus 10 equals 15. The opposite of addition is subtraction. Remember, we said that subtraction will undo addition. So we're going to do minus 10 on this side. Remember the golden rule, whatever you do to one side, you do to the other. Do minus 10 on this side. So over here, I'm going to get 0. So I'm going to have x plus 0, which actually just leaves me with x. And I can bring down my equal sign. On this side, I'm going to get 15 minus 10, which gives me 5. Bring my equal sign down here. I'm going to bring down my 5. I've got a line where my equal signs are. So my answer is x equals 5. So let's go back and plug it in. My original equation was x plus 10 equals 15. If I plug in this 5 for my x, I'm going to have 5 plus 10. 5 plus 10 is going to equal 15. And that is correct. So again, what did I do? I had x plus 10 equals 15. I used my inverse operation and subtracted 10 from both sides and found that x equaled 5. Okay, let's look at a few more. Several more, actually. Here's my first one. Negative 18 plus y equals 12. Again, I want to use my inverse operation. This is a negative 18. The opposite of a negative 18 is plus 18. So I want to add 18 here. I also want to add 18 here. So right here I'm going to get 0. I'm going to bring my y, bring down my equals. 12 plus 18 is 20. So I find out that y equals 20. And if I checked that over here and did negative 18 plus 20, remember, same signs, add and keep, different signs subtract. That's the same as doing 20 minus 18. Wait a minute. This is not 20. This should be 30. 18 plus 30 should give you 12. Good catch, Miss Ernest. So we should have y equals 30. All right, let's look at the next one. Negative 5n equals 25. Remember that when you have a number and a variable sitting right beside each other, it means you multiply. So for this one, the inverse of multiplication is division. So I'm going to divide both sides, not just by 5, but by negative 5. I'm going to divide this side by negative 5. So over here, my 5's will cancel out, and I'm just going to be left with an n. I'm going to bring down my equal sign, and I'm going to have 25 divided by negative 5. Well, 25 divided by 5 is 5, and then I have to remember my rules for positives and negatives. Positive divided by a negative is going to give us a negative 5. So if we went back and checked this, I would have negative 5 times negative 5, and that should give you positive 25, which is what we started with. So let's go up here and do this one. I have 3/4 times x equals 9. Okay, so for this one I'm multiplying here. To undo multiplication, I'm going to divide. So I want to divide by 3/4. Well, remember, dividing by a fraction is the same as multiplying by its reciprocal, or we called it the refliprical, where we flipped it over. So 3/4 divided by 3/4 is the same as multiplying by the reciprocal, or 4/3. Now remember, when we do this, we can go ahead and cancel out to begin with. So we would make this a 1, make this a 3, and we do 3 times 4. We find out that x, because these will cancel, equals 12. Now, if I went back in and multiplied this through and did 3/4 times 12, what do I get? Well, 3 times 12 equals 36 divided by 4. That gives me 9. I have a 9 here and a 9 back up here where we started. So our answer should indeed be x equals 12. Okay, let's look at one more example. This one has decimals. Notice that whether I've worked with fractions, negatives, positives, they've all been the same. So if I'm dealing with the decimal, it's still going to solve the same way. I use an inverse operation and I isolate the variable. So here I have m minus 2.5. The inverse of subtraction is addition. So plus 2.5 here, plus 2.5. Okay. Different signs, subtract and keep the sign of the larger number. So 0, 1, keep the sign of the larger number, bring down my m, bring down my equals. So m is going to equal negative 1.0. And if I plugged it back in and did negative 1.0 minus 2.5, this is a negative minus something. I can do same switch change. I would end up with negative 3.5, which is also what I started with.